My name is Harry Filet. I'm the director of the Drill and Completions Lab here at the University of North Dakota. I'd like to take this opportunity to invite you inside and we'll take a little tour of the lab quick. First off, thank you for coming into the lab today. What we want to do is take the opportunity to show you all the safety features that we incorporate in the lab and how real world we can actually get this lab for the students that come here and take this lab from the University of North Dakota. So first off, you'll notice we don't have a lot of stripes on the floor right now. This lab is still new. We're just now finishing up the completions, trying to get things running, so it's going to take us a little bit of time to get the floor stripes and get everything in, but we kind of have an idea where we want it all to go. So right in here is considered the safety zone. We're going to have a yellow stripe on the floor here. We do not need PPE in this specific area because there's nothing that can fall on us. There's nothing that should be happening over in this corner. But the minute we leave this corner, you will need steel-toed shoes, safety glasses, hard hats, and different apparatus as we go through all the different equipment that we're going to be operating. So again, that area is going to be in this general area here. And then we're going to walk through lane upstairs to an observation room. We built an observation room into this SCR house for people that don't need to be on the drill floor but want to observe the drilling going on, whether that's CEOs of companies, whether that's field engineers, whether that's people who are developing new drill bits or whatever, they want to watch the process. We don't want them on the drill floor when we're actually drilling because it's a safety concern. So what we have here is Neighbors Drilling has donated an SCR house to us. This is the exact same SCR house that they use in the field today. So if you were to go to an oil drill site, you would see an SCR house like this. What that does is controls all the electricity throughout the entire platform. So every electric motor on here will run through that house. So that house is our #1 concern for water, fire, and only authorized personnel are in that house. So if we walk this way, now right now, we would be violating that line, but nothing's running right now. So as you can see, we need steel-toed shoes, we need hard hats beyond this point. So once we come in here, you can actually see this is a Triplex Mud Pump. This is the real exact same mud pump that's used in industry today. A couple semesters ago, the students had rebuilt the entire unit. We have 3 new pistons, 6 new valves. We redid the upper end and the lower end. The reason that we do items like this is these students will never get their hands on this equipment ever again. You know, when they come through this program, we're hoping to give them real world experience touching, handling, and working on real equipment. So how the system is set up right now is we have our 2 mud tanks right here. We have our centrifugal pumps in the middle. The centrifugal pumps control all the flow, whether we put it back in the tank, whether we go up top to actually the sand hopper, which is where we mix our sand. Once we mix water and sand, it's called mud. So we mix our mud up top there, and that's all controlled by this centrifugal pump. We got 2 pumps here. We can draw out of one tank or the other tank, and then we can also discharge that into our Triplex Mud Pump, and then it goes off into our drill head, which cools the bit and carries the cuttings out of the hole. So as you can see right here, the tower moves back and forth on these rails. This tower will never move with anybody on the floor. We have the control right here, and it's a manual control switch. So whoever is driving this thing forward and backward has to be the only one in charge of it. Nobody else can be on the floor while the tower's moving. This creates huge pinch points, and as you can tell, with these gears open in the back here, I don't know if you caught that or not, but the shields are not on yet. The shields are laying on the floor over there. I put the shields on, they didn't fit right, so I'm remaking them so that they're safer. So there's huge pinch points on this side. This whole top deck moves up and down, and the tower moves back and forth. The top deck is 35,000 pounds, the tower is 20,000 pounds. There's 55,000 pounds of crushing force that we have to be cautious of at all times. So we come over here, this is our workbench where we can do light work on different things at the top there, and that's the driller's control cabinet up top. The driller's control cabinet is where the driller is going to actually sit and run this entire operation and talk to everyone on radios that are staged in different areas, and the stage people are going to be just watching gauges and different things and upsets that are going to happen, but we want everything controlled by the driller because that's how it is in the real world right now. We have one person that runs everything. So if we continue to tour around this way, we can see over here is our hydraulic room. This is where all our hydraulic pumps are that run everything on the rig up and down and confining pressure. We have our flammable cabinet in the back. We have all of our oil and grease in that flammable cabinet. If we pan over to this side, you can see the other flammable cabinet that's across the drill section. That flammable cabinet is all of our aerosols and solvents in it. We didn't want to mix the oils and the solvents, so we have them in two different flammable lockers. You can see over here we have all of our hanging tools. These tools are all huge, they're heavy. This wrench weighs over 150 pounds. So all of this is lifted with the crane. We don't do much of the lifting with this by hand, because even if you do pick the wrench up, you're not going to supply the torque you need. You're going to get hurt trying to use these tools. So when we get the tower moved over top, this is where a sample holder is. Our cores actually go down inside of here. Runs 5 feet deep and 16 inches around. We run our drill bit down to that. The cutting mud will come out of there carrying the cuttings, and then go to screen 1, which is a low pressure screen, screen 2 or high pressure screen, or screen 3, which is our atmospheric screen. So once the mud comes through here and screened out the cuttings themselves, the mud actually goes back to the tank, and we do the whole process over again. We have the hydraulic or the fiberglass arm here, so that when we're actually cutting or doing anything with moving of the rig, actually doing the drilling, this arm goes down so that we restrict the area so that nobody else but authorized personnel are on this floor right here. Because as I stated earlier, it's a lot of weight, things are moving around, you got pinch points all over the place. Every student that takes this lab is well rehearsed on the pinch points, where to be, how to stay out of the way. Because again, if we're picking up these wrenches, we're going to be using the crane, there's things that can happen. Something can break and that strap is going to want to fly one way or the other. They're all trained on which way that strap should fly and to stay out of the slap zone. So we have pinch points, we have slap zones, we have all kinds of concerns we have to be cautious of. And of course we got high pressure cutting fluid, so we need safety glasses and other PPE to make sure that people aren't getting sprayed in the face with cuttings and sand, things like that. So once we leave here, talking about the cuttings, we'll go over to the Slurry Loop. The Slurry Loop was a project that I built a couple years ago for a grad student. What he wanted to do was watch the transport phenomenon in real time. So what we did was we put together this apparatus so that he could actually pump the cutting mud with cuttings in it and watch how those cuttings are transported out of the hole. So how this whole thing works, we have our tanks over there, goes to the pump. Then when it comes out of that pump nozzle, it comes up to this hose here. When it goes into this hose, it goes up the entire circumference of this apparatus. This is a clear PVC pipe on the outside. On the inside is a stainless steel pipe. The clear PVC mimics the well bore, and the stainless steel pipe mimics the drill bit. So we have about a 1-inch angular section where we can watch the cuttings being transported up. Now this whole thing will tilt straight up in the air and all the way down. As you can see, there's multiple pinch points on this piece of equipment. This entire track can get your pinch. These arms can get your pinch, the pinch point up front there, and this entire thing comes all the way down, so that's another pinch point. So the only people operating this, the only people in this area when it is operating, are people who are well rehearsed on how this thing works, meaning the people who actually built it, which is myself and Dr. Fawad, and we will train anyone who's going to futuristically take over this project, because we got one person that's assigned to it right now, but when we get more people that are working on this, that must be in the top of their mind at all times, is where are the pinch points, where are your hands? At the end of the day, you want to go home with all 10 digits. So coming around this way, you can see all the different sands that we've used in this process. And this is the actual cuttings that come out of the drill rig. So it's not a specific size, but they are very sharp and very angular, and that's why we wanted it out here, so we can take the cuttings out of the drill rig and put them right into this apparatus and get real world conditions on the Slurry Loop. So the big wooden structure behind us, Dr. Forrest Ames from Mechanical Engineering is putting a wind tunnel out here. If we walk around to the front end, this will actually be the inlet end where the arrow comes in. That's what all this wood here is on the floor, is he's building a flow straightener for the inlet side so that he straightens out the air on the way into his wind tunnel. So as we come around, you can see he's got the flow straightener, which is going to live here, and then he's got this screen that he's using for a pressure drop, and then he's got a converging nozzle for the entire wind tunnel. This entire cross section is the wind tunnel. There's a section missing out of the bottom center of the floor there. he's going to put a load cell in there so that he can tell lift and drag and different things that are occurring, whether it's on a turbine blade, whether it's on the Formula One race car that the students build every year, or whether it's on, they're going to fly a couple of UAVs in there. So they've already got plans for it. They've already got some grants that they're going to be writing on it. So we're thinking shortly here it'll start making money for us. So if we walk around to this way, the safety factors for this really aren't, they're putting mesh or cargo netting in both sides. There's not a whole lot more that they have to worry about because things get in there and you shut all the doors and no one's in there when the wind tunnel's on. That is one of the safety features of this. Dr. Ames did set it up so that you cannot be in there with the fans turned on. So as we come over to this side, the entire side over here is the Rare Earth Element Extraction Project. This is a project that's headed up by the Institute for Energy Studies, which is a division of the College of Engineering and Mines. What they're looking at is how to get rare earth elements from North Dakota lignite. Right now we only have one producer of rare earth elements in the world, and that's China. So having us depend on China to supply rare earth elements for things like high intensity magnets, all of our cell phones, TVs, cameras, every computer chip thing has rare earth elements in it. So we need rare earth elements to produce all of these things for everybody that we consume every day. So inside these black barrels here is North Dakota lignite. This lignite here has been ground and prepared and it's ready to go in the process. Once they get the process up and running, they'll pump this in a slurry, and in that slurry will be a weak acid mixture which will extract the rare earth elements from North Dakota lignite. As we walk over here, this floor here is actually going to be a driveway, so we are going to straighten this out as a driveway because we need access over to the drill rig, access to the wind tunnel, and access from the garage door. So as we come over, you'll see the garage door, which is where we bring in all of our big stuff. We have two pieces of equipment that can haul things in. We have the forklift over there, and we have the Bobcat here. So we need a driving lane for these pieces of equipment so that everybody knows that there could be a vehicle moving in this lane. Once we get that lane set out, this entire area over here will be a hard hat, safety glass, proper PPE, steel-toed shoe area, because they're going to be mixing things, they're going to be pumping slurry, and the ability to get splashed, the ability to have something fall on you, the ability to get something in your eye is really high over here. So this entire area will be a hard hat, safety glass area. If we keep coming over this way, we can see the grinding room. The grinding room is where they prepare all their coal. So all their coal that comes in fresh from the mine, comes in multiple different sizes. They need it all sized down to a certain size, and here's where they put it up in that conveyor belt and crush and grind it. This room is very dusty, very dirty. Whenever they're in this room, they have to wear hard hats, safety glasses, and they have to have on their breathing apparatus. So the PAPR is a battery-operated breathing apparatus that runs through a big filter, and it's a fresh air supply always, so that they won't breathe in that dust from there. Everything else on the outside over here is kind of our fabrication area. You can see there's multiple cutting, turning, chopping items which are very dangerous. We run through them right now. So over here we have a cut table, and then we have our Ellis bandsaw, and we have our cut saw. In this area over here, you will need your safety glasses on at all times, because even if you're not the one cutting, if somebody else is cutting, these are spinning blades that things can come off and send pieces of metal all around this entire area. So if we come around to this side, we have our gas storage area over here. We have our oxygen acetylene cut torches. We have our tanks which are filled and ready to go. They're strapped off right now. If we need to run out of welding gas or whatever, it's in that bundle. We can bring it and weld with it. Come over here, we have a plasma torch, our hydraulic press. You can see everywhere throughout the entire building that we've been shooting, you see these big fire extinguisher signs. And there are fire extinguishers throughout the entire building, almost on every post, or at least every other post. So there's fire extinguishers throughout. With the movement of this coal around, that's probably about our only biggest flammable item in here is the coal dust. So we try to do a really good job of cleaning that coal dust and not having it linger in the area for very long. So we have our mill here, which again is a turning piece of machinery. You gotta be super cautious not to wear gloves when you're operating this. It'll suck your hand in. You gotta wear your gloves. gets loud, so you have your hearing protection. And then we have our iron workers, which again, all the safety symbols are here. We have our safety sign up top. This actually shears the metal, punches holes in metal, bends metal. So again, parts can come flying off of it, things can happen. We have our belt sander in the back. We have our welding table up front here, and then we have our lathe, which we just bought. So again, this is a huge turning safety issue. We got to be careful that no one's around this when it's not running. This one actually has a really neat safety feature built in. It will not start with this lid up. So that lid has to be down in order for it to start. So that's good to keep people's fingers and toes away from the back top area. Okay, if we keep coming around this way, we can see the female's locker room here. This affords the students out here the opportunity to store their dirty clothes out here, whether it's just a pair of coveralls or whether they want to completely change into different clothing. We have lockers out here for them to store their PPE, whether it's a hard hat, safety glasses, gloves, and their dirty clothes out here. This is the female handicap side, and then the men's is over here. So the men's locker, we do have a shower in there. One thing I was going to show before we got to this section, we have an eye wash station here. This is going to be converted over to a full shower. The reason being is the rare earth element process uses a dilute acid. Well, if you were to get that on your clothing, you want to wash it off as soon as you possibly can. So the way in which we do that is we'll put a shower in here for a shower station so people can shower off. We do have showers in the men's bathroom, but that's a long way to go. If you get some acid on you, you want it really close and quick so you can get it washed off right away. So as we come into the smaller lab up front here, this is a lab where the guys from Institute of Studies can actually do some of their small laboratory experiments. You can see there's a lot of equipment laying around. This is where the control room is going to be, sitting over there for all that process out there so they can control the entire process. Then there's some laboratory equipment up on the benches over there so that these guys can do smaller scale stuff to make sure they're actually getting the rare earth elements that they want to. We have our hard hats and coats, so when people walk in right away they can grab a hard hat, grab a safety jacket, whether it's the full coveralls or just a welding jacket to protect the upper torso. And here's our safety glasses, so they can grab a set of safety glasses, they can grab hearing protection on the way in, so they can get all their PPE stuff on before they get out into the lab itself. I'd like to thank you for your time and watching this video, and if there's any questions, don't hesitate to ask. Thank you.